Okay, guys, question 4D. Two integers differ by 3. The sum of their squares is 317. What are the two integers? Okay, so I'm just going to let x represent one integer. One integer. And then since I know the integers differ by 3, so if one of them was 1, the other one could be 4, for example, I'm going to let x minus 3 represent the other integer. I think you could also use x plus 3 too, right? Because they just have to differ by 3, so it doesn't matter which direction. Okay, so then it says the sum of their squares is 317. What are the two integers? So the sum of their squares, so that means if you squared them and then added them. So their squares are x squared and x minus 3 squared, and sum means to add. So in the description says the sum of their squares. So their squares are when you square each one, and the sum is when you add it. So that's the expression that we're looking for right there. What are the two integers? Oh, the sum of their squares is 317. Forgot that part. So that is equal to 317. And we have to find out what the two integers are. So this is just a quadratic equation right here. So I'm going to go ahead and expand this whole thing and make it look a little bit more like one of the formats we're used to, like standard form. So I'm just going to expand this x minus 3 squared bracket. So this bracket actually means x minus 3 times x minus 3, which ends up being x squared minus 6x plus 9 equals 317. And then if I bring everything to the left-hand side and collect my like terms, then I have 2x squared minus 6x. And then I have plus 9 minus 317. So what's that? Negative 308. Yeah, I hope so. Okay. So now, yeah, I just have a quadratic equation, and I'm trying to find out what my integers are. And x is my integer, one of my integers. So I need to find the value of x, because it asks me what are my two integers. So I just need to solve this equation in any way that I can. So we could try to factor it if it's possible. I think everything's divisible by 2. So maybe I'll just factor out a 2 right off the bat. And I didn't even do that. So I'm just dividing everything by 2. What's 308 divided by 2? 154. Is that right? Yeah. 154. That makes sense. Okay. So now, if this is factorable, I need to find something that multiplies to negative 154 and adds to negative 3. I have no idea at the top of my head, so I'm just gonna try some stuff. But if you didn't know, you could just use the quadratic formula, right? I think that might be faster. I'm not having much luck right now. 154. No. Oh, 14 and 11. Yes. Okay, so I found 14 times 11. So if I make it negative 14 times 11, then I get negative 154. And if I do negative 14 plus 11, I will get negative 3. Perfect. So then I can factor that into x minus 14 and x plus 11. And now I can just solve. If you couldn't factor that, you, like I said before, you can just use the quadratic formula too if you'd rather do that. Okay, so now solving, I get x is equal to 14 and x is equal to negative 11. So I actually have 2 integer values that this is true for. So since x represented one of my integers, then it looks like 14 is one of my integers. So I'm just going to answer the question over here. 14 is one of my integers, and negative 11 is the other one. And then x minus 3 represented my other integer. So 14 minus 3 is 11. So 14 and 11 is one answer. And then negative 11 is my other answer. So negative 11 minus 3 is negative 14. So I actually have like 2 possible values. So the original question says this 2 integers differ by 3, which these both do. The sum of their squares is 317. So if I squared 14 and added it to the square of 11, do I get 317? Let's check. 14 squared plus 11 squared is 317. Check. And obviously you can also have negative 14 squared plus negative 11 squared, because once you square 14, negative 14, you're just going to end up with the same thing as you would have when it was positive. So therefore both of these answers are correct. So the question said, what are the 2 integers? So you would say the 2 integers are 14 and 11, or negative 11 and negative 14. So that's your options for 4D. Awesome.